Hi, welcome to my channel. In this video, we want to find all triples x, y, z that lie between 0 and half and which satisfy the equation 2x plus 1 over 4x minus 1 times 2y plus 1 over 4y minus 1 times 2z plus 1 over 4z minus 1 equals 1 minus 2xy over z times 1 minus 2yz over x times 1 minus 2zx over y. First, let's show that 2x plus 1 over 4x minus 1 is greater than 0. We do so by writing the expression as x plus 1 over 4x minus 1. Next, let's examine the term x plus 1 over 4x. Writing it as square root of x whole square plus 1 over 2 square root of x whole square. We complete the square by using the identity a square plus b square equals a minus b whole square plus 2ab. For our case, a equals square root of x and b equals 1 over 2 square root of x. So we get square root of x minus 1 over 2 square root of x whole square plus 1. Inserting it into our expression, we obtain x plus square root of x minus 1 over 2 square root of x whole square, which is greater than or equals to x, which in turn is greater than 0. Thus, we have shown that 2x plus 1 over 4x minus 1 is greater than 0. Similarly, we have 2y plus 1 over 4y minus 1 is greater than 0, and 2z plus 1 over 4z minus 1 is greater than 0. Therefore, the left-hand side is positive. Since the left-hand side is positive, this implies the expression on the right-hand side is also positive. Since the expression on the right-hand side consists of 3 factors, we either have 2 factors that are negative, with the third factor being positive, or all 3 factors are positive. Suppose 1 minus 2xy over z is negative, and 1 minus 2yz over x is negative. Then 1 minus 2xy over z is negative, implies 2xy over z is greater than 1. And 1 minus 2yz over x is negative, implies 2yz over x is greater than 1. Next, we multiply these inequalities to obtain 2xy over z times 2yz over x is greater than 1. This simplifies to y squared is greater than 1 over 4, which after taking the square root, we obtain y is greater than half. This is a contradiction since y is less than half. Similarly, any pair of factors being negative will lead to a contradiction. Therefore, all 3 factors are in fact positive. Having shown that all the factors on both sides of the equation are positive, next, let's consider this expression, which is the square of the first factor on the left-hand side, minus the product of the first and third factor on the right-hand side. First, let's evaluate 2x plus 1 over 4x minus 1 whole square. Expanding the bracket gives us 4x squared plus half minus 2x plus half plus 1 over 16x squared minus 1 over 4x minus 2x minus 1 over 4x plus 1. After combining like terms, we obtain 4x squared minus 4x plus 2 minus 1 over 2x plus 1 over 16x squared. Next, let's evaluate the other term. Expanding the bracket gives us minus 1 plus 2zx over y plus 2xy over z minus 4x squared. After combining like terms, we obtain 1 over 16x squared minus 1 over 2x plus 1 plus 2zx over y minus 4x plus 2xy over z. First, let's simplify 1 over 16x squared minus 1 over 2x plus 1. Writing it as 1 over 4x whole square minus 2 times 1 over 4x times 1 plus 1 square. We make use of the identity a squared minus 2ab plus b squared equals a minus b whole square, with a equals 1 over 4x and b equals 1 to obtain 1 over 4x minus 1 whole square. For the term 2zx over y minus 4x plus 2xy over z, we factor out 2x over zy to obtain 2x over zy times z minus y whole square. Since x, y, and z are positive, our expression is greater than or equal to 0, with equality if and only if 1 over 4x equals 1 and z equals y. 1 over 4x equals 1 is equivalent to x equals 1 over 4. Therefore, to summarize, we have 2x plus 1 over 4x minus 1 whole square minus 1 minus 2xy over z times 1 minus 2zx over y is greater than or equal to 0. With equality if and only if x equals 1 over 4 and z equals y. By moving 1 minus 2xy over z times 1 minus 2zx over y to the other side, we obtain 2x plus 1 over 4x minus 1 whole square is greater than or equal to 1 minus 2xy over z times 1 minus 2zx over y. With equality if and only if x equals 1 over 4 and z equals y. Similarly, we can show that 2y plus 1 over 4y minus 1 whole square is greater than or equal to 1 minus 2xy over z times 1 minus 2yz over x. With equality if and only if 1 equals 1 over 4 and z equals x. And 2z plus 1 over 4z minus 1 whole square is greater than or equal to 1 minus 2yz over x times 1 minus 2zx over y. With equality if and only if z equals 1 over 4 and x equals y. Next, we multiply all these inequalities to obtain 2x plus 1 over 4x minus 1 whole square times 2y plus 1 over 4y minus 1 whole square times 2z plus 1 over 4z minus 1 whole square is greater than or equal to 1 minus 2xy over z times 1 minus 2zx over y times 1 minus 2xy over z times 1 minus 2yz over x times 1 minus 2yz over x times 1 minus 2zx over y. The right hand side simplifies to 1 minus 2xy over z whole square times 1 minus 2yz over x whole square times 1 minus 2zx over y whole square. After taking the square root, we thus obtain that the left hand side of our original equation is greater than or equal to the right hand side. Next, we need to determine the conditions for equality to be reached. To do that, we turn back to our three inequalities. The first equality holds if and only if x equals 1 over 4 and z equals y. The second equality holds if and only if y equals 1 over 4 and z equals x. And the last equality holds if and only if z equals 1 over 4 and x equals y. From this, it follows that equality holds if and only if x equals y equals z equals 1 over 4. Therefore, the solution to our original equation is x equals 1 over 4, y equals 1 over 4, and z equals 1 over 4. As an exercise, try to solve this equation and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.